How does a free body diagram of a car going through a banked turn at constant speed relate to its acceleration? So for this question, I have another series of pictures, so I think we'll just go through them here. It says here's a car in a right turn that is banked. The view is from behind, and let's start an FBD. So that's kind of similar to a previous example. View is from behind, but now again the car is inclined a little bit because it's on a banked turn rather than a level turn. We're going to need a system point, so we always do that, right? The gravity force is going to point down, even though the turn is banked, right? Gravity still points down. But similar to like inclines that we've looked at, like if an object is sitting on an incline or accelerating down an incline, basically a banked turn is like another kind of incline, right? It's maybe a little different in the sense that, it kind of continuously adjusts through the turn, the direction of the incline, but still it's like an incline, we're going to think of it. So that means the normal force is going to be adjusted from vertical to kind of respect that direction of banking. In other words, this normal force better be at right angles to the road that this car is going over here. All right. So the traction force, now this is an interesting one. This is maybe a hard one to guess. It says must point along the road surface. And again, we're using words here. So like in this class, Physics 2A, we'd probably say F sub G, F sub N, and maybe this would actually be F sub F because we know traction really is static friction. If this car were just parked here, the static friction force would have to point the opposite direction. It would point kind of up the incline to prevent the car from sliding down, which is what would occur if there were no friction. But we're talking about a car going through a turn, and unless the car is going really, really slow, most likely if there were no friction, like if this were ice, really slick ice, the car would start to slide out of the turn towards the outside as a result of that lack of traction. So that tells you that traction force is preventing that, so hence it must point to the inside, because really for friction the rule is it points in the direction that the object would tend to move or want to move if it weren't there. So that's kind of one way of validating that guess that we have. Now to see how all of this works, we're going to do what we often do, is we need to look at the net force, right? Which means we're going to have to move the forces one by one over into another picture, because we're going to do this geometrically here. We weren't given any numbers, we're not doing calculation, so we're just going to arrange them head to tail. We're going to do traction next. We're going to do gravity there, so all the forces are arranged head to tail. The net force is there in the gap between all of those, and okay, so that's kind of cool. Does that make sense, right? So by itself, I've removed all those just to look at the net force, and it points in the direction that we might expect. Why is that? Well, the direction of the acceleration is still horizontal. This is something I've seen occasionally a pitfall or confusion about. It's like, should the acceleration be horizontal or should it be at some angle because we're on an incline? Well, the thing is we're still going through a turn, and the car is going, in that sense, through a trajectory that itself falls into a horizontal plane, you could say. So its centripetal acceleration, in other words, the center of the turn, has not gone down just because we're on an incline, not just because the turn is banked. So it's still going to be horizontal, right? If we bring back the head to tail diagram, now we can ask another question, because it says here, does it seem like a banked turn would require more or less traction? So even without doing a calculation, it's useful to be able to manipulate forces based on pictures and look at the connection between the different forces, the net force, and the acceleration to answer a simple question. And my answer to this is the banked turn would require less traction, because if the turn were not banked, the net force would simply be equal to in that case, horizontal traction force. But this picture pretty clearly shows that the traction force is of a shorter length than the net force, so hence the less traction is required. Another way of putting that is that means the maximum speed the car could go would be higher, because the maximum speed kind of corresponds to whatever the maximum of traction is, and that's going to presumably be higher if less of it is needed.